All right, so this was the formative question today that a lot of us struggled with, so I'm going to go ahead and work through this one. Notice it's asking, given the function f of x equals 8 over x cubed plus 8, find the minimum value of f on the interval negative 1 to 2. Now, I need to remember that if I'm looking for a minimum, that really means that I need to figure out where the critical values are. Oh, that's not what I wanted to use. Critical values. And so that really means I really need to figure out where is f prime of x equal to 0 or undefined. So I know that that's a spot where the minimum could happen, a max or a min. But I also need to remember that I can check the endpoints. So if I go ahead and I need to start doing this, so for me, when I look at this, f prime of x, I'm really noticing that it seems like it's quotient rule, and while I would love to avoid that, because you know I'm not a huge fan, I just don't see a way to. So I'm going to go ahead and use the quotient rule there. So low the d high minus high d low all over low squared. Now notice I'm not multiplying out the denominator because I really want to figure out when the derivative is 0. Okay, don't really need the denominator for that. And where's the derivative of undefined? And again, if I look at the denominator, maybe having it multiplied out is going to make it look more complicated for me. So let's say we're looking for when the derivative is 0. Well, if I know the derivative is 0, well, maybe I want to clean that up first. It's really negative 24x squared over x cubed plus 8 raised to the second. So if I want this to be 0, then that means I really need the negative 24x squared to be 0, which really means that I'm going to want x to be 0. And so that's a critical value. All right. Next, let's suppose I want it to be undefined. That really means I want this to be, equal to undefined. That really is going to happen if my denominator is 0, so I want x cubed plus 8 squared to be 0. But noticing, like, do I really care about that square? I mean, I could square root both sides, right? So ultimately, I'm realizing I can just get rid of that square since I'm square rooting both sides and just say that. Which then I could solve. I mean, that's going to be x cubed equals negative 8. Which if I cube root both sides, like what cubed would make negative 8, I would end up getting, so if I cube root, maybe I'll show you that, just so we realize that it's happening. We're going to get x equals negative 2. Which I don't care about because that's not even in the interval in question. See? So, all right, so on that interval, on the interval negative 1 to 2, the only spots that I could get a minimum would be potentially at 0. So the spots that I care about right now are 0, and I care about negative 1 because that's an endpoint. Endpoints are important, and 2. And so if I really want to figure out what the minimum is, well, I could either try to identify is x equals 0 a min, but ultimately, do I care? I mean, I only have 3 points where it could happen. Why not just find the value of them all? So if I put 0 into the equation, I'd end up with 8 over 8, which is 1. if I can draw. And at negative 1, well, if I put negative 1 in the equation, I would end up with 8/7. And if I put 2 into the equation, I'd end up with 8/2. Sorry, 8/16. Thinking ahead, which is really 1/2. So what is the minimum? Well, there it is, folks. And I'm going to erase my work just so I can make a nice final tidy statement for you. And I would say f has a minimum of 1/2 at x equals 2 on the interval -1 to 2. And there it is. Hope this helps. Have a good night.